Hi. So, good morning. Last class, what we have learned? We have learned about object detection, right? So, object detection is your module 3. So, last class, I have briefed you what is the difference between object detection and image classification. So, today, we are going to see some of the architectures which are particularly formulated or created, proposed only for object detection. Okay, so before I'm jumping to the architecture directly, we will again go through the brief about object detection, localization, etc. And then we will talk about the various architectures which are especially proposed for object detection. Okay, so as in the figure, we all know object detection equals we need to classify the object as well as we need to say the location of the object where it is from the background image, right? That is clear. See, so what was last class? What we have done? Object detection algorithms and classification algorithms are differ with a bounding box. Okay, only the thing added in the object detection is a bounding box, that is called as object localization. That is, we are drawing a bounding box around the object of the interest. Object of the interest means which object we wanted to locate, or from the image if we have 3 or 4 objects, we wanted to locate all those 4 objects, so the bounding box across all those 4 objects, and we wanted to say that object is a car, this object is a lion, or this object is a dog or duck, whatever it is. Okay, so from 2000 to 2020, from 2000 to 2020, we have, or the scientists or the researchers have formulated one architecture on the top of the other by improving their accuracy, speed, different computational speed, efficiency, cost, accuracy, or in all those things, the researchers tried to optimize. And okay, so from these are the things like they have started. Initially, they have started with the Hogue features for classification. And sorry, object detection. Then real-time face detection as a problem statement they came. Then they have started with DPM overfit. Then came as RCNN, that is region proposed convolutional neural network. Then fast RCNN, then faster RCNN. Then YOLO came. YOLO is you look at once. So all these architectures we will get to know in meanwhile. So this is just a journey of object detection architectures. Okay. Now, again, this is object detection algorithm. First there is an image. Then we need to the algorithm we will apply. Then after the output, what it will be, in this image we are going to detect it as a vehicle only. We are not saying that it is a car or it is a bike. Okay, because both are the car, so we have mentioned it as a vehicle, and there is a bounding box. Okay, now one question is arise, what is the difference between object localization and segmentation? Okay, segmentation, I hope you all might know about segmentation. So what is the difference between segmentation and classification or localization, object localization? There comes in this figure. See, the first figure, that is this one. The first figure, this one, this is of image classification. That is, we are going to classify this particular bird as bird, and we have the classification as a multi classification. That is, in the image there are bird is there, sunset, dog, and cat is there. So when this particular image comes, the image classification model classifies it as a bird. Okay, this is the binary class. NX binary classification means it's a multi classification. Okay, now what is image segmentation? Image segmentation is this image. This is image segmentation second. Image segmentation में क्या होते हैं? In image segmentation, it will cluster out, or it will group the similar pixels together, and the exact point, see, the image or the segmented output image is exactly on the top of this person, right? And this person, this is segmentation. Exact pixels will be clubbed together. But what happened in image localization? That is the third figure. In image localization, we are not going to exactly draw we are not exactly going to group together on the boundary, right? The boundary of the cat ears is like this. It should be like this if we are going for an image segmentation. But, right? But what is localization? In localization, we are just telling inside this box, there is a cat, like that. That is, we are locating the object, but we are not segmenting out from the foreground is the cat image and the background is the grass image. So we are not going to segment it out. That is the difference between classification, segmentation and localization. So object detection comes with image classification and image localization. These two clubbed together and we will get a object detection algorithm. Okay, I am writing here object detection. Here we are not going to segment out the region of interest. Understand? Okay. Now, now we are going to tell why we cannot do this object localization with a classifier, right? For a classification, we do have certain architectures like VGG, AlexNet, LayNet, etc. We used for image classification in the last class, MobileNet, EfficientNet. Why can't we use those architectures for object localization? There is difference because the length of the output layer is variable, right? In one image, the vehicle, one car is of different variable, that cat is of different variable, maybe the I mean the one which is nearer to the image when we are seeing from this side, okay, from the front side, the thing which is nearer to us will be bigger and the backward images are smaller, so there will be variation in the scale size. So a naive approach to solve this problem would be to take different region of interest from the image, right? So what will in object classification, what will they do? They will try to take different region proposals. That is, in an image, we divided that image into different region proposals, and each region proposals are again different areas of interest. Those of interest, once we created, and we will take it and we will give to the CNN for extracting the features. Then we are going to classify it. So if we are using all these things within classifier architecture, the problem arises is with spatial locations within the image of different objects and different aspect ratios. So we need to select a huge number of regions, and this will computationally blow up and it will not be computationally efficient. I mean, if we are going for an architecture for a problem statement, it should be computationally efficient. So that will not happen in this case. So I'm here concluding what are the different challenges in the object detection. Like what we have said here, this car is of smaller size, but this truck and this car and this truck is of different sizes. So different filter size, different spatial locations is required. Now another change is what? Occlusions, right? What is occlusion? See, this is an occluded image. Occlusions means overlapping. Okay, that is, one person is overlapped with a building in front of him or a tree in front of this person. Sorry. So this is an occluded image. So in occlusions, what happens? See here, many persons are occluded, many persons are overlapped together, but the object detection algorithm is tried to detect like this. This is also overlapping. So there is also challenges arises. Okay. Now here, what happens here? Different background, different lighting. There is difference between the images. right? See here, the hair is visible, but if we change the background, the hair is not visible. So like that also differences are there. What happens here? This is intra-class variability. That is, all are dogs itself, but again these dogs are having in different breeds, different species. So again the problem arises here. Am I correct or not? Because intra-class variability, for this also our algorithm should be efficient for generalizing for these purposes also. So for all these problems we come up with again one more problem. This is background cluttering. Background cluttering means the foreground images and the background images are little more cluttered together. The colors are more or less similar. So in this way also it has to draw a bounding box around this, right? So for all these challenges it has to go for which one, our algorithm. So for this purpose we have created a different set of architectures for particularly for object detection. Okay, which are the other architectures? RCNN, fast RCNN and faster RCNN we will see in the next video. Okay, thank you.